There are three approaches to problem solving: experimentation, simulation, and mathematical model, which are classified as analytical or numerical. It is possible to obtain an exact solution for analytical problem, whereas a numerical problem will yield an approximate solution. In science and engineering, we set up experiment together information and data, test hypothesis, and compare theory and practice all sorts. The result are expensive experiments typically require a large amount of expensive equipment and facilities. As a result, scientists and engineers are also using simulation to solve a problem. Simulation are defined as a model of representation of a series event in science, engineering, and business. Presently, through computer calculation to study effects of potential and on decision. Problem statement: a constant temperature, pressure, volume. The thermodynamics process work can be calculated is W, integration of B and AP dV, differentiation of velocity. Where W denotes P works, pressure, and denotes volume. Given the data of the table below, compute the work. W is a combination of trapezoidal rules, Simpsons over three rules, and Simpson 3 over 8 rules. All three rules must be included in computation. Pressure P Pascal 300 is a volume with 0.5 meter cubes. 287 1.5 meter cube. 276 2.5 meter cube. 258 4 meter cube. 251 7 meter cube. 239 is 8 meter cube. 190 is 10 meter cube. So based in show, this is of our Fila table is a facts work produced by a constant temperature in a thermodynamic process. Idea work in thermodynamic can be calculated using a pressure, volume, and thermodynamics. Learning issue: how do you calculate work in a thermodynamic process? To calculate the work, use the trapezoidal rule, the Simpson 1 over 3 rules, and a Simpson 3 over 8 rules. Objective: to identify the approximate method to be used in this project. Calculate tabulated work. To determine the combination of trapezoidal, the Simpson 1 over 3 rules, and Simpson 3 over 8 rules. To determine the volume of under the graph of the calculated data. This is the data from a thermodynamic process. So the Pascal is 300, and also the volume is 0.5 meter cube. 287 1.5 meter cube. 276 2.5 meter cube. 258 4 meter cubes. 251 7 meter cube. 239 8 meter cube, and 190 is 10 meter cube. This is trapezoidal method. Formula of trapezoidal method, you can see F. So the integration by, you can see the volume, no, the Pascal of the project. We conclude all the data and integrate, and 9.5 over 2 result of the integrates times with 2004, and you got 900 9590. So this is a calculation for 1 over 3 Simpson method. Formula 1 over 3 Simpson method is that odd and even. So for this 1 over 3 Simpson method is a different method from a trapezoidal. So you can see 10 minus with 0.5 out over 6, and you got a 1.5833. So this is stable or carry over. So 1.5833 divided by 3 is a sum of 490 plus 4 times with 784, and plus 2 times with 500, minus 27. This is in the formula. So you get a 2469.95 kJ. So this is a formula for 3 over 8 Simpson method. B differentiate. So B minus with A times with N. So N is how many datas in a Simpson table, 3.8 Simpson table. So you got a 10 minus with 0.5, you divide by 6, and you get 1.5833. So this is a table for the Simpson 3.8 Simpson rule. So we start with 0 and end with 6 for I, and xi is x times with the value of, I think, value of the uh, meter cube. So 0.5 is the start, and we got a 490 and 1553 and 258. So you got a 24,000 and 2,472.92 kJ. So this is the result of each method. For trapezoidal is 9,590 kJ. 1 over 3 Simpson method is 2469.95 kJ, and 1 3 over 8 is 2472.92 kJ. For the literature review, the thermodynamic process. A process is a road along which one sub the attribute divide from the initial value and the state of the system change. There are six different categories of a process related to the thermodynamics. Adiabatic, no heat transfer from the ore to the fluid. Isothermal, no change in the temperature of the fluid. Isobaric, no change in the pressure of the fluid. Isochoric, no change in the volume of the fluid. Isotropic, no change of the entropy of the fluid. Isenthalpic, no change in the enthalpy of the fluid. Interpolation is carried out using a strategy that necessitates a first expression of numerical data by a suitable polynomial and calculating the value of the dependent variable, because a method of expressing a given set of numerical data on a pair of variables by a suitable polynomial is necessary. First, Newton's split difference methodology is presented using the linear and quadratic interpolation techniques. The split difference polynomial of Newton will be next discussed in some of its widest aspects. The primary idea is to characterize interpolating the polynomial using the Newton form, which take into account linear variable that impact interpolation sites. This study is using a tabulated data of a thermodynamic process given to identify the numerical method used in civil engineering.
Next is for the methodology. For the methodology of our project, we use three rules, which is trapezoidal rule, Simpson's 1 over 3 rule, and Simpson's 3 over 8 rule. For a trapezoidal rule is a numerical analysis method for approximating the definite integral. Trapezoidal rule is integration rule that divides a curve into a smaller trapezoids in order to estimate the area under a curve. The summation of all areas of small trapezoids will give area under the curve when underlying function is smooth. This rule does not provide the exact number as Simpson's rule does. This is caused by the fact that Simpson's rule employs quadratic approximation rather than employs linear approximation. Both Simpson's rule and trapezoidal rule produce an approximate number for the integrals, but Simpson's rule produces an even more accurate approximation value. For the Simpson 1 over 3 rule, this rule requires two minimum segments, where the trapezoidal rule only one. We generate area with n equals to two segments under Simpson's rule using Newton forward distance difference up to second order. And last, for the Simpson's 3 over 8 rule, this rule is also called as Simpson's second rule, another method for numerical integration proposed by Thomas Simpson. It is based upon a cubic interpolation rather than quadratic interpolation. Next is for the methodology. For the methodology of our project, we use three rules, which is trapezoidal rule, Simpson's 1 over 3 rule, and Simpson's 3 over 8 rule. For a trapezoidal rule is a numerical analysis method for approximating the definite integral. Trapezoidal rule is integration rule that divides a curve into a smaller trapezoids in order to estimate the area under a curve. The summation of all areas of small trapezoids will give area under the curve when underlying function is smooth. This rule does not provide the exact number as Simpson's rule does. This is caused by the fact that Simpson's rule employs quadratic approximation rather than employs linear approximation. Both Simpson's rule and trapezoidal rule produce an approximate number for the integrals, but Simpson's rule produces an even more accurate approximation value. For the Simpson 1/3 rule, this rule requires two minimum segments, where the trapezoidal rule only one. We generate area with n equals to two segments under Simpson's rule using Newton forward distance difference up to second order. And last, for the Simpson's 3/8 rule, this rule is also called as Simpson's second rule, another method for numerical integration proposed by Thomas Simpson. It is based upon a cubic interpolation rather than quadratic interpolation.
For discussion, as previously mentioned, a number of variables including the original function. The selected limits the quantity of strips, and the numerical approach utilizes effect accuracy. The result of a technical analysis using the trapezoidal method, 1/3 Simpson rules and 3/8 uh, Simpson Simpson rules are as follows: 9,119 kJ and 2469.95 kJ, 2472.92 kJ, respectively. The exact definition of these error terms is outside the purview of this course, but it is important to note that generally for functions with the increasing, then the appropriate combination of the two in Simpson rules eliminate these error terms, giving a rule that is perfectly module anything up the cubic and have a proportionally lower error of any function of a greater complexity.
Right. Based on the calculation and observation that have been done on the study, it can be concluded that between both 1/3 and 3/8 Simpson's rule method is the best and most accurate method to solve this problem. Through this study, it is clear that there are some circumstances in the nowadays field of civil engineering that call for the employment of a numerical technique to identify pattern characteristic. This now numerous well-known function that could not be solved using analytical method might instead be solved precisely thanks to the numerical method. The numerical method provides a different approach that will streamline the calculation process and help the engineer to resolve any problem involving civil engineering in less time while keeping the accuracy. These methods are applicable in real-life situations. In order to generate young generation with problem-solving skills, these numerical methods are demanded to be utilized in their daily lives.